Welcome back. So now let's simplify some radicals. All right, so we have 5 times the square root of negative 121. All right, so now we could rewrite that radical using the product property. We could rewrite that as the square root of 121 times, you can put parentheses if you want, times the square root of negative 1. All right, so product property, you can write this in your notes. The root of a product equals the product of the roots. All right, so we can split that radical into 2 radicals and have that as a product of those radicals. Well, we know the square root of 121, that's a perfect square. That's 11. How about the square root of negative 1? Well, we know that's I. So now we just multiply those together, so our answer is 55i. So in your notes, add any time we have the square root of a negative number, we will have I. Okay? So you see a negative number, and you're taking the square root of it, think I. Let's do another one. All right, so we have negative square root of negative 96. And by the way, I don't think I mentioned, when you have a coefficient outside the radical and you simplify the radical, remember you multiply the coefficient times whatever comes out of the radical. All right, so we have the negative square root of negative 96. All right, let's rewrite that using our product property. All right, so we're going to have negative, and we're going to have the square root of 96. And we're going to have times the square root of negative 1. Well, we know the square root of negative 1 now, but 96, right? Well, that is not a perfect square. So we're going to simplify that. All right, well, what divides evenly into 96? Well, let's see. 4 divides evenly into 96. You could have said 2, but 4 does go in evenly. All right, so 4 divides into 9, that would be 2 times. I'd have a leftover. So 4 would divide into 16 4 times. Right? And, well, 4, or 24 is not prime. Neither is 4. But I'm going to leave the 4 alone for now, because 24 is just 4 and 6. All right, so I've got a pair of 4s. So, I mean, I could simplify those to 2 and 2. Right? And 1, 2 comes out and 1, 2 goes away. But maybe we'll just keep it as 4s. Right, because 1, 4 could come out and 1, 4 could go away. Since they match, let's just leave them. Now 6, that's 2 and 3. Right, well, I have a pair of 4s, but I'm left with a 2 and a 3. So that can't come out of the radical because there's not another 2 and there's not a 3. Right, so when I simplify this, we're going to have negative. The 4 can come out of the radical. Right, and square root of 6 is stuck. And we still have to deal with the square root of negative 1. Well, we know that's I, right? So we're going to have, and actually we'll just write it over here. Now, we shouldn't leave it like that because that's not a conventional way to write this. We should multiply the numbers together that are outside that radical. So we should write that as negative 4i and then have the square root of 6. So by the way, don't have the I next to the square root of 6 on the other side, because it could, if I didn't put parentheses there, it could look like the i's under the radical, and it's not. All right, so that's our simplified answer, negative 4i square roots of 6. All right, let's do another one. All right, so we have negative square root of 12. All right, so we can split that into a square root of 12 and a square root of negative 1 using the product property. Well, 12 is also not a perfect square. Right, so it's divisible by 4 and 3. And 4 we can split into 2 and 2. All right, that's as factored as we can get the 12 to be. Right? And so we have a pair of 2, so 1, 2 comes out, 1, 2 goes away. We have a leftover that stays in a radical prison, right? We can't take that 3 out of the radical. Right? So we're going to have 2 square roots of 3, that would be 12. And we know the square root of negative 1, that's I. So let's multiply the things that are not in a radical together. So we have 2i, and then we have the square root of 3. And there now we have that in simplest form. We have simplified that radical. I think I have one more. I think this is the last one. I'm almost positive. Nope, that's the last one. Yep, I'm positive. All right, so let's do the last two together. All right, so we have 2 times negative square root of 36. So you can add this to your notes. If there's a coefficient in front of the radical, multiply the coefficient by terms that come out of the radical. So we can just add that to our notes as a little reminder. All right, so product property, we have a 2, we have a 36, a square root of 36, and we have a square root of negative 1. Right, so using the product property for radicals, we have split that into 2 radicals. I'm going to put a parentheses here too. Now let's simplify. Well, 36 is a perfect square. Square root of 36 is 6. And square root of negative 1, that's a perfect square. Square root of negative 1, that's I. So now we can just multiply all 3 terms together. 2 times 6 is 12, so we have 12i. And there we go. Right? And we have simplified another one. Let's look at one more. So we have negative 1/3 times the square root of negative 63. Right? Let's use the product rule, and we will split this into 2 radicals. So we have the square root of 63 times the square root of negative 1. 63 is not a perfect square. Right, we can divide that into 9 and 7. 7 is a prime number, so that's it. 9 is not, and that would be 3 and 3. So we have a pair of 3's. 1 3 comes out, 1 3 goes away. Right, so when we rewrite this, we have negative 1/3 times 3 square roots of 7, and we know that the square root of negative 1 is I. So we need to multiply everything that's not in the radical. So that would be this, that would be this, and that would be this. Right, so 1/3 of 3. Well, if you take 1/3 of 3, you're only going to have 1. And if that's not sure, right, if I put the 1 there as a fraction, the 3's would cancel. I'd be left with the 1. But since that's negative, it's going to be a negative 1. Right, so negative 1/3 of 3, that's just negative 1. And times I. So I don't really need to write negative 1i. I can just write negative I. And left in the radical is the square root of 7. So there we go. Now that's as simple as it could be. All right, so thank you for watching Simplifying Complex Radicals. Radicals with complex numbers, as they're get complex numbers when we simplify. And in the next lesson, we're going to be solving, and we might have some complex numbers as our solution. All right, so bye for now.